Sigasi Visual HDL 2025.2 introduces powerful new visualizations for state machines and adapts seamlessly to your existing design flow. Sigasi projects can be trivially configured by your existing tools, or making SVH the cockpit of your design flow, driving downstream tools via the exportable compilation recipe. SVH 2025.2 brings transformative new features for the state machines diagram view. First up, let's open a state machines diagram. You can immediately see some new additions. The reset state is marked by a dashed arrow. If you double-click the dashed arrow, we go to the reset transition. Similarly, there is a dashed arrow going out from 0 onto a question mark. This is an unresolved state. If we double-click the transition, we can see a small design error is present. Finally, we have dead states, marked by a red outline. Double-clicking brings us to the state, and indeed, this state has no outgoing transitions, only incoming. If we now define the one constant, we can see that unresolved transition is resolved. Finally, adding a transition to 0,1 resolves the dead state. The final addition is constant name visualization. You can see the constant name 0 in the state, instead of the bit vector literal 00. If we were to use the bit vector literal in the code, the constant name is no longer used in the state machine diagram. Had we made a mistake and made the bit vector too large, we now also get new warnings. The same occurs if the bit vector is too small. Most people using SVH already have their project set up in a different tool. To prevent you from doing double work, keeping projects in sync over tool chains, and redefining the project multiple times, SVH introduces Sigasi projects. I'll show an example, but before we get started, I have to ensure we have the Sigasi project setting enabled. Now, I've cloned the open source UVVM project here, and of course, it's already been set up by its design team to work with existing tools. It mentions a Getting Started file. Let's have a look. I see that the easiest way to compile the complete UVVM with everything is to run the compile all shell script. So let's try that. First, we create a new Sigasi project by right-clicking the Explorer view and pressing Add Project, Sigasi Project, UVVM as name, and press OK. You can see that a project.sigasi file was created with some default configuration. Let's remove the default configuration and fill in the compile all command that was mentioned. No reference was made to any environment variables, so let's remove that part. First, go to the root script directory, and then run the compile all command. Save the project.sigasi file and watch the magic happen. In the background, we list the files analyzed by your tool and use that to configure SVH. Going back to the Sigasi view, we now see a design and a targets node. The design perspective allows navigating the structure of all directories that contribute to the project. The target perspective reveals the logical structure of the project, with all the files sorted according to your tool's compile order. Once we open a file, SVH starts right up. We have hovers, autocomplete, and all the other usual SVH productivity features. Your project will automatically be kept in sync with your toolchains through the compile all script. No more project setup duplication needed. Simply instruct SVH on how to build your design using your existing tooling. Now, this was one way of fitting SVH into your design flow, but some of you do it the other way around, using SVH as the cockpit for their design flow. This is now also possible through the compilation recipe export. Simply run the export compilation recipe command. choose the entire project. For reuse, it's best to use relative paths. And finally, open the compilation recipe.json file that was created. This JSON has all the information you need to compile your project. It mentions file groups, which library the files belong to, their language level, the include directories for Verilog, as well as the initial defines. Following this, you'll find the actual files, in the correct compile order. Scrolling down, there's another file group, this time compiled as Verilog 2005 instead of System Verilog. The file concludes with a few more similar file groups. The compilation recipe once again ensures you don't have to duplicate your project description. But this time, SVH is the single source of truth. You can use the compilation recipe to power all your other tools, turning SVH into the cockpit of your design flow.